Hello, I would like to introduce you to Libosmscout. Libosmscout is a C++ library for OpenStreetMap for offline vector rendering, routing, location lookup, and point of interest lookup on mobile devices. So why offline? One main advantage for offline routing and rendering is you can use the application without a central server. You don't need any central infrastructure. Your software still works if you have no network, or the network is unreliable or slow, or network access is too expensive, or network can break down even in crisis, or if you travel by train or similar. And the other main advantage is that you have a copy of the OpenStreetMap database, or an optimized and reduced version of the OpenStreetMap database on your device. So you can render live on the device. You do not need any tile server, and you have far more flexibility regarding changing of style sheets or filtering and presentation of data. So why a library? When I started to try to draw a map using Libosmscout based on OpenStreetMap data, it took me a week for the first map to get drawn. But it took me far longer to get the database small, and the rendering is routing fast, and the memory footprint small enough to get it really working reasonable or even fast on the mobile device. And there's still some more room for improvement, for optimization. The other problem is that if you want to work based on OpenStreetMap data, you have to care of a lot of things. This is a small list of the things that came into my mind within 10 minutes I had to cope with when working on the library. So that means, in principle, there's room for more than one application that's based on OpenStreetMap data. You do not want only a copy of Google Maps application, but you have many applications that just try to show a map or give you some lookup of points of interest or similar. And every time such a map, such an application is written, you have to re-implement all this stuff again and again. So if you want to build a cool application based on OpenStreetMap data, you should put your time into the application and do not spend too much time working on the OpenStreetMap data format. And this is the task of the library that does all these dirty OpenStreetMap parsing and handling and optimization stuff for you. So Libosmscout is written in C++. It's licensed under LGPL with some exceptions for iOS to get the applications based on it into the App Store. It's a library framework to offer ready-to-use functions for map drawing, rendering, routing, points of interest search, and location search, and is solely based on OpenStreetMap data. And it's just all the ugly stuff you have seen a few slides before, and tries to give you some simple APIs so that you quickly can get a rendered map in your application. And it works well under reduced resources as you have on mobile devices. Of course, it also works on the desktop. The idea is that you import your OSM or OSM-PFBF file on your development machine. You then let the importer do all these crunching of the data, and you get later on you get some database files in a proprietary format and index files, and you can then test on the desktop the resulting database and the style sheet. You can optimize and change the style sheet, and later on you can copy all the stuff, the database, onto your mobile device and the style sheets, and then you can use it offline. So the library tries to be layered on service-based. So on the lower level, you have some helper classes that do some fundamental things like logging, file access, some geo crunching. And then on top of that, you have the database, data types for OpenStreetMap, like nodes, ways, and areas. On top of this, again, you have a type config system and tag handling system. And Further up the layer, you have the importer, and in parallel you have the style sheet and the renderer. And you have on the left side the database files and index, which together with the database, and based on top of the database, you have a number of services that work on the data that are provided by the database. The advantage is that you can that you do not need to use the whole library, but you can use only parts, for example. So there are users that, for example, exchange renderer, use a different renderer, but use the database for fast providing of high quality data. But could also exchange other parts or can add new services or even extend the database with additional files. So it's also customizable. You can only import the data you are interested in. For example, if you're not interested in rendering trees on your map, you can just drop it from the database. So of course, the database then gets smaller. You can add more data, get a bigger database. You can change the style sheet or even write multiple style sheets to draw only the things you are interested in the way you like it. You can have influence on the zoom level, things appear, and have some style sheet syntax to influence the look too. And there are a number of configuration options to influence the speed and other parameters of the renderer. The number of objects that get drawn, the detail of the object that get drawn, other stuff. And of course, you can add additional renderings on top of the actual map. You can add contour lines or other overlays. And for the routing, that is also integrated, you have the possibility to use routing profiles to influence the routing decision. For example, build different profiles for routing for cars or bicycle. Supported platforms is desktop. You can use, for example, Qt via the Qt backend. You can use GNOME or develop under Windows using the Cairo backend. You can develop and use it under Mac OS X via Cairo, or even better, there's a native backend for iOS and OS X rendering. On the iPhone or iPad, you would use also the iOS X backend. For Android, you have the possibility to use JNI. Or you can use also Qt that is available for Android to implement applications. Windows Phone, I haven't tested it. I must admit that I'm unclear what the situation is. But for platforms that are not supported, where you cannot work with C++, you have still the option to work directly on the database files. So you can write your own front and your own parsing code. The database files are rather simple. The code for reading the database is it's only a smaller part of the library. Most part is the import. So import you do not have to rewrite. The library is in fact multiple libraries. So you have the Libosmscout library that contains all the basic stuff. You have the map rendering base library that contains backend independent functionality. You have the importer library that contains all the functionality of the import. The import library is used by the importer. That is normally a simple command line application, but you could write your own importer too. Rendering backends supported currently are libhgg, Cairo, iOS, and OS X, and Qt. There's some code for generating SVG files, but I stopped working on it because it was unclear how the SVG file actually look. There are different approaches to render data into the SVG file. So there's not only one solution, it's more like a template, how you could use it. And there's also beginnings for an OpenGL library backend, but this is, has to be improved to be useful. Okay, this is an overview for the relevant data that's generated. There's more data generated, more files that get generated during the import, but these files are only used by the import itself. This is the files you have that you have to copy to your mobile device to get the functionality. You do not need to copy all the files. For example, if you do not need routing, you do not have to copy the routing database path. So on top of, you have some files, small files containing the metadata, the type information, the bounding box. Below, on the left side, you have the actual data for nodes, areas, and ways. In the middle, you have index files for searching for nodes, areas, and ways based on bounding box lookup. And there's also 2 files for optimized rendering of areas and ways in low zoom situations. So the polygons are much smaller, the ways are smoothed, and the amount of data is smaller, and that means that you can render much faster in low zoom levels. You have a location index. The water index file contains information regarding coastlines and tiles that are ground or tiles that are water or ocean. You have the intersections, a list of intersections that is later on used by the router to generate descriptive routing information. And then you have the routing data files for routing for food, for bicycle, and for car. If you do not need all the routing files, you can, of course, drop some of them. The total size of all files, I have an example for North Rhine-Westphalia. Germany, the OSM PBF files is around 375 megabytes. The complete data shown here have a size of 641 megabytes. Half of it is for the upper part, and the other half is for the routing information. Reducing the size of the routing files is one major task in the future. So this is an overview for the relevant classes you will see if you want to access the library. Of course, the library itself has much more classes, but most are used internally. So we have a central class, of course, is the database itself. It's a database parameter class to handle parameters for the initialization. We have the type config class. Then you have 4 services: location service, point of interest service, map service, and routing service, and below the relevant classes that you should be aware of if you want to use a special service. For example, for location service, we have several visitors that allow you to traverse the tree-like structure that is built using the index. Okay. You have style sheet. Style sheet is cascading style sheets based. It's special for the library. It does not use another defined syntax. On top, you see that you can define the order of ways that get rendered. So which way is rendered on top of which other way. Then you are able to define a number of constants. It's planned to allow to change the constants from the application. And, for example, if you have constants for color, it allows you to change the style sheet coloring without writing a second style sheet. And on the bottom, you see an example for the actual rendering of highway motorway. This is only the line part. The style sheet syntax does not contain the label or the one-way errors you see in the bigger version. There are 2 alternatives. You have a simpler rendering for low zoom, and you have a more complex structure for rendering in higher zoom levels. So these are rendering examples. This is a zoom in on North Rhine-Westphalia. The rendering engine supports tile rendering, so you can integrate into existing tiling frameworks. You have various tuning options. You have coastline rendering, fast coastline rendering. The support for icons. The rendering is DPI aware. You have rather intelligent labeling. It supports Unicode. You have way overlays for example, for one-way errors. You have overlay labels. You can see this in the 3 images on the left. Some fading effect with bigger labels, and of course custom extensions are possible. So I have one user that integrates 3D rendering, and you can add contour lines. So this is an example for the routing. You should not look in detail into the actual routing description. The router is an R star, uses R star. It generates separate files for car, bicycle, and food. It generates a routing description. That is what you see in the background. Of course, this is just an internal test application. It evaluates speed limits, surface quality, turn restrictions, one-ways, and a reasonable subset of access rights. And the profile is customizable, so you have rather big influence on the actual routing decisions. So you could even input some live traffic information, which is not part of the library, but you could integrate it. This is an example for location search. On the left side, you see a search for Signal Iduna Park in Dortmund. That is a football arena. You get an exact match. You see, as part of the match, you get the complete region tree behind this area, and you get the ID of the area itself. The farther below, you see other hits that are not exact matched, but matched partly. On the right side, you see another lookup for a specific address, my former place of living. Okay, that's it. Thanks for all the committers for the library, all the users, and thanks to you. I can, in the end, show also now a video from a user that used the application, the library on the iPhone, so you get an impression how that looks like. The first part of the video, he uses a tiling approach. In the second part, he switches to the actual live rendering. So the tiling approach, the tiles are cached. In the live rendering, it's rendered directly on the map. So we get an expression of the speed of the library. Okay? Questions?
Okay, thanks a bunch, Tim. Tim told me before the talk that we can begin or start with a question and answer session while the video is playing in the background, correctly?
Yeah.
Okay, so any questions? Please announce your name and the country you're coming from before you speak.
Yeah, hi, I'm Thomas Bremer from Germany and actually from Nordrhein-Westfalen, from Nordrhein-Westphalia. Maybe we're neighbors. Anyway, two questions. First one is about code size and status. So you said this is still work in progress. How much of the functionality, just a brief description, is already finished, and how many lines of code does it consist of? And second question is just answer with yes or no. Is there a binary for Android available?
The library is still under active development, so I'm still improving the library. The file format, for example, is not yet fixed, but most of the code is usable on the system. So what you see is already working and functioning. And I'm, of course, trying to improve the performance mainly and add new features. So yes, code size, I admittedly do not have any number of lines available. I would have to message itself, myself. And what was the last question? Android, no, I cannot provide binary yet because one of the users did a Qt build, and I'm currently trying to reproduce the Qt build and get to build my own library. But the building itself on Android already works, but I haven't generated an APK. And there's somebody working on the JAI access for using the library via Java. There's an older example that is not compatible to the current API anymore, but in principle, JNI is working.
So, further questions for Tim? None so far? Okay. One further question?
I have actually two questions. First, what is the license of the library?
LGPL with iOS exceptions, as told.
Okay. And my second question is, do you plan any supply chain for the data files? Some download server to load tiles or anything? Or is it up to the user to supply the applications with the data?
Currently up to the user. I'm currently trying to concentrate on the functionality of the library itself. Of course, at the time I have the feeling the library is finished, I would take a look at other more high-level things if they are not already done by somebody else.
Thanks.
So, not yet.
Hi, I'm Markus from Karlsruhe. Is there an API or import process for enhancing the data with own POIs?
With what?
With own POIs, not with address data, not in OpenStreetMap, like a customer layer or similar.
So you want to enrich the import with external data?
So I understood you have to prepare the file formats the library needs. So can I integrate more than only OpenStreetMap data?
The complete parser is based on the OpenStreetMap format and is very close to the data structures of OpenStreetMap. You can add further data if you want to add further indexes, for example. If you want to enrich the information with one of the existing indexes or data files, you would have to change the code.
Okay.
Yeah.
Okay, further questions for Tim? We still have a couple of minutes left. None so far. Tim, may I ask you a question? What about big data files? Have you experience about data trying to convert Germany or Europe or even the whole planet?
Converted several countries. One major pain was France, but in the end it worked. The import speed mainly depends on the memory you have. So if you give the importer more memory, then things get faster. I think France must be now around 1 hour. North Rhine-Westphalia takes 6 minutes. Yeah.
So, I'd like to thank you a lot. Maybe a short applause for Tim.
Thanks.